Hello viewers, welcome to Senior College Mathematics. Topic of discussion is bearing. Lesson 7, Reversed Bearing, Problems from WAEC, Part 5. We have example 21. A cyclist starts from a point S and rides 3 kilometers due west to point Y. At Y, he changes direction and rides 5 kilometers northwest to a point Z. Roman figure 1, how far is he from the starting point correct to the nearest kilometer? Roman figure 2, find the bearing of Z from S to the nearest degree. Solution. A cyclist starts from a point S. So S is the starting point because he followed west to Y. S needs to be somewhere here. Then this is west. From this west, the cyclist moved to point Y. From Y, he followed northwest to point Z. This is north, this is west. So he followed this direction, then he gets to Z. We can join these points together. So here is 5 kilometers. This line should be longer than this because this is 3 kilometers. You label accordingly and you find the required parts of the question. You have the diagram well labeled. You have S, you have Y, and you have Z. We are asked to find the distance between Z and S. To do that, we need this angle for us to use either sine or cosine rule. This is one quadrant, 90 degrees. Remember, the angle here is 90 degrees, but the angle between north and northwest, half of that quadrant is 45 degrees. So this angle is 45 degrees. You have to visit lesson 1. This was well taught in lesson 1. So here is 45 degrees. Here is 90 degrees. If you add both together, this entire angle is 135 degrees. We know the two other sides. To get this side, this is side Y, this is side S, this is side Z. It has to be by cosine rule. So you have SZ squared equal to YZ squared plus SY squared minus 2 times YZ SY, then cos Y. So SZ squared is equal to 5 squared plus 3 squared minus 2 times 5 times 3 times cos 135 degrees. After simplification, you have this result and this result. To get SZ, you need to take the square root of both sides, and SZ is equal to 7.4305. To the nearest kilometer, you have 7 kilometers. Roman figure 2 of the same question. The bearing of Z from S. You need to go to S. You start movement from the north to this place. This is third quadrant in clockwise direction, 270 degrees plus this angle here, theta. So the required bearing is 270 degrees plus theta. Theta is needed, which is obtained using sine rule. Already we know this side, it is complete, the angle and the side. So you write the sine rule in terms of the complete side in this form. SZ, okay, YZ over sine theta equal to SZ over sine 135 degrees. You have it in this form. What we use here is the original value, not the approximated one. To make theta stand alone, you need to cross multiply and divide both sides by this. If you evaluate the numerator, you have this result. Divide it by the denominator, you have this result. To get theta, take the inverse of sine of both sides, and you have 28.41 degrees. Therefore, bearing of Z from S is 270 degrees plus 28.41 degrees, and that is 298.41 degrees. To the nearest degree, you have 298 degrees. Example 22. The position of three ships P, Q, R at sea are illustrated in the diagram. The arrows indicate the north direction. The bearing of Q from P is 050 degrees. That is what you have here. And angle PQR equal to 72 degrees. Calculate the bearing of arrow from Q. Arrow from Q, you go to Q, and you move from north to the line joining arrow and Q together. But we need to adjust this point. So let's have the complete 4 cardinal points here. So let's take this one down. So this angle here 50 is equal to here 50 degrees. So to have this 72 degrees, this part must be 22 degrees. That is what you have here. The required bearing is from this point to this point. This whole side is 180 degrees. You simply subtract 22 degrees from it, and you have 158 degrees. The correct option is B. Example 23. The bearing of Q from P is 150 degrees, and the bearing of P from R is 015 degrees. If Q and R are 24 kilometers and 32 kilometers respectively from P, Roman figure 1 represents this information in a diagram. Roman figure 2 calculate the distance between Q and R, correct to 2 decimal places. Roman figure 3 finds the bearing of R from Q, correct to the nearest degree. Solution. From the first statement, the bearing of Q from P, you have to start from P. It is a rough sketch. If the rough sketch is not in accordance with the question, you can always adjust it. So let's take this as point P. The bearing of Q from P is 150 degrees. That is the second quadrant clockwise. So we have Q somewhere here. So this is point Q. The second statement, bearing of P from R. This is P now. This is P. Then from R, this value is in the first quadrant. In order to connect P and arrow, you need arrow to be somewhere here. So this is arrow. The bearing of P from arrow is 15 degrees. Then you can match this together. Then you close this part. So this point is P, this point is Q, and this point is arrow. The question says that between Q and P, the distance is 24 kilometers. So you have Q and P. Here is 24 kilometers. Then arrow, between arrow and P, it is 32 kilometers. So here is 32 kilometers. So you have this sketch. This sketch represents the information. So you have the diagram where labeled. I've already done this previously. So from here to here is 150. To have 180 on this side, this angle must be 30 degrees. This place is 0.15 degrees, which is equal to this part. So if you add the two angles here, you have 0.45 degrees. This 30 here is equal to this 30 here. You have this side and this side. You are asked to find the distance between Q and arrow. So the angle facing this side is known. That is 0.45 degrees. And you have the two other sides. It must be cosine rule, where you have Q arrow square equal to P arrow square plus PQ squared minus 2 times P arrow times PQ times cos P. You have it in this form after replacing the various parts with what they stand for. After simplification, you have this result and this result. After subtraction, you have this. To get Q arrow, you need to take the square root of both sides, and you have 22.6692, approximately 22.67 kilometers to 2 decimal places. Roman figure 3, the bearing of arrow from Q. You go to Q. You start from the north to the line that joins arrow and Q together. So from here to here is 180. We need this angle to add to 180, but before then you have to get this angle 30 degrees. If we are not going by that, we know that all the angles in the 4 quadrants is 360 degrees. To get from this point to this point, you need this angle theta. You add it to 30 degrees and subtract the sum from 360 degrees. So the bearing of arrow from Q is 360 degrees minus theta minus 0.30 degrees. Theta can be obtained using sine rule. This side is complete, so you state the sine rule in terms of this complete side along with this side. You have the sine rule in this form. If you make sine theta the subject, you have this result. After simplification and division, you have 0.9981. To get theta, you take the inverse of sine of both sides, and you have 86.4787 degrees. The bearing of arrow from Q is equal to this. After subtraction, you have this. To the nearest degree, you have 244 degrees. Example 24. Three ships, P, Q, and arrow, are at sea. The bearing of Q from P is 30 degrees, and the bearing of P from arrow is 300 degrees. If PQ is equal to 5 kilometers and P arrow equal to 8 kilometers, Roman figure 1 illustrates the information in a diagram. Roman figure 2 calculate correct to 3SF the part 1 of Roman figure 2 distance between Q and arrow. Part 2 of Roman figure 2 bearing of arrow from Q. Let's see the rough sketch of the information. Bearing of Q from P. So let's say somewhere here is P. The bearing is 30 degrees. That is in the first quadrant. From P you go to Q. So somewhere here is Q. The second bearing is that of P from arrow. P from arrow 300 degrees. Already you have P here. In order to join P and arrow together, we must have arrow somewhere here, and the bearing is 300 degrees. That is in the fourth quadrant in clockwise direction. So you have this point to be 300 so that you can join both together. After which we can swear join these points together. So if from here to here is 300, we can get this angle. Then from here to this place is 30 degrees. So here is 30 degrees. You have to label the sides correctly to enable you complete the solving. You have the diagram as I have illustrated. This is point P, you have point Q, and you have point arrow. This angle here is 30 degrees. Is 30 degrees. And this whole quadrant is 90 degrees. So from this point to this point alone is 60 degrees. We need to get this other angle. If you come here, from here to this point is 270 degrees. So to this point is 300. This angle is 30 degrees, which is equal to this angle 30 degrees. If you add it to 60 degrees, you have 90 degrees. That is how you have this angle. Then you label the other sides. This is side arrow, this is side Q, this is side P. In order to find the required bearing, we need to label this angle to be theta, this is alpha, and this angle is beta. Meanwhile, this angle also is equal to this angle, 30 degrees. Distance Q arrow is by Pythagoras rule, because this angle is 90 degrees. So you have a right angled triangle. You can well use cosine rule, but that cos part of it will be 0, because cos 90 is 0. So that from minus 2 times the product of the two sides times cos of the angle will be 0. So you are left with the first two parts. So Pythagoras rule is more appropriate. So this side becomes the hypotenuse, the longest side. So Q arrow squared is equal to sum of squares on the other two sides. Q arrow square is therefore equal to 5 square plus 8 square, that is 25, plus 64, you have 89. To get Q arrow, you take the square root of both sides, so Q arrow is equal to square root of 89, and you have 9.43 kilometers. That is part 1 of Roman figure 2. Then part 2, bearing of arrow from Q. Bearing of arrow from Q, you need to go to Q. You start from the north to the point that connects Q and arrow together. All of this side is 180 degrees. So once you get this angle here, subtract it from 180 degrees, that is the required bearing. That is 180 degrees minus beta. And the way it is, for us to get this angle, we need this angle because both angles are equal, alternate angles. And for us to get this angle, we need theta. You see that? And because we have a right angle triangle to this angle, this is opposite. You have this is opposite, this side is hypotenuse, and this is adjacent. So to get theta, we use tangent. So tan 30 degrees equal to opposite over adjacent, that is 5 over 8, and you have 0.625. To get theta, take the inverse of tangent of both sides, and you have 32 degrees approximately. It follows that from alpha to theta to this place, 30 degrees, the whole of the quadrant is 90 degrees. If you add the three angles, the sum is equal to 90 degrees. You replace theta with 32 degrees. So the alpha becomes 90 degrees minus 62 degrees, the sum of these two angles, and that is 28 degrees. Therefore, the bearing of arrow from Q is 180 degrees minus 28 degrees. That is alpha, and it is equal to beta. The bearing becomes 152 degrees. End of lesson 7. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess Him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.